right, we are back. This is Techmath1. We're looking at Chapter 7, and that is on geometry. So, Blue Book, page 282. And this is Chapter 7. Okay, so if you take a look, number 2 is 50-degree angle is called an acute angle. If it's less than 90 degrees, it's acute. Just think of it as a cute little angle. Let's see, 125 degrees is an obtuse angle. Back in the olden days, obtuse also meant if you were not very bright, you would say obtuse. It was in, what's that really good movie? Stephen King short story, or was it a novella or something like that? Shawshank Redemption. He really sets off the warden when Andy Dufresne says, "Don't be obtuse. If I turn you in, implicate myself." And he's like, obtuse, obtuse, and he really goes nuts about it. So back in the old English, obtuse also meant kind of like slower, not smart. But for our purposes, it means an angle bigger than 90 degrees. So if it's bigger than 90 degrees, it's obtuse. If it's less than 90 degrees, it's acute. So obtuse, acute. Let's take a look at number 3. Supplemental and supplementary angles and complementary angles. If supplementary angles, they have to add up to 180 degrees. So a lot of times you'll see like a straight line with supplementary. And like if this is angle 1 and this is angle 2 and they tell you angle 1 is 50 degrees, well then angle 2 we can find, because if this is 50 degrees and a straight line is 180 degrees, then you just subtract 180 minus 50 and you get 130. All right, that's supplementary. Complementary angles add up to 90 degrees. So if you have a right angle, a marked right angle, and then they split it, but not exactly in half, and they say, okay, angle 3 is 60 degrees. What's angle 4? So if angle 3 is given as 60 degrees, you can find angle 4 because it's complementary. Complementary. Not like when you get something free, it's spelled different. It's complementary. It's still pronounced complementary. But there's an E instead of an I. So complementary, that's 90 minus 60 in this case. So that would have to be 30 degrees. So if you know they're complementary, they add up to 90. If you know they're supplementary, they add up to 180. They do not have to be adjacent angles. Adjacent angles mean they have a shared side. So if you wanted to be fancy, if you were like talking about the apartment next to you, like if this wall were to another apartment, that would be the apartment adjacent to you when you have a shared wall. Okay? It's adjacent. Fancy. All right, so what about 2 lines cut by a transversal? Look on page 284. 2 lines cut by, 2 parallel lines cut by a transversal. So what does that look like? Now that looks like this. You've got a parallel line and another parallel line. So 2 lines that'll never cross. They're on the same plane. And then if a third line goes through them, that's called a transversal. So it's a transversal line. And now after that, if you just know one angle out of all of these angles, 1, 2, 3, 4, 5, 6, 7, 8. If you just know one angle given, you can find all the angles. So let me show you how that works. So if they tell me angle 1 is 130 degrees. So they just gave me one angle here. They just gave me this one. It's 130. Well, then I know all the rest of them. Because look, if this is 130 and this is on a straight line, it has to add up to 180. So that has to be 50 degrees. If that's 50 degrees and this is a straight line, well, then that has to be 130. If that's 130 and this is a straight line, then that has to be 50, because they always have to add up to 180 no matter what. So vertical angles are always the same. That's 130 and 130. Vertical angles are congruent. That's 50 and 50. Those are vertical angles. And then when you have two parallel lines, that means that this line makes a 130 degree angle when it hits this line. But since this line is parallel, it's just translated down, this would also be 130. So those are called corresponding angles. And then this is going to be 50, and this is going to be 130, and this is going to be 50. So there's some things that you can just like memorize where you just go bing, bang, 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 like a, you know, a zigzag. These are called alternate interior angles. They're interior angles because they're inside of the parallel lines. So interior angles, alternate interior angles are always the same. So the 50s are those, 130s are always the same. And then the outside ones were called corresponding angles. So a corresponding angle always has an exterior because it's outside of the parallel lines, and an interior. So 130, 130, 50, 50, 50, 50, 130, 130. All right. Okay. Let's take a look at number 6. 3 types of triangles. We've got equilateral, we've got isosceles, and we've got a right triangle. So a couple of things. If it is equilateral, sorry about that. If it is equilateral, it's also equal angular. So look, if all of these sides are the same, then all of these angles have to also be the same. And all these, the interior angles of any triangle has to add up to 180. So if they're all the same and they have to add up to 180, they have to be 60. Just 180 divided by 3 is 60. If they all have to be the same, we could just divide 180 by 3. So 60, 60, 60. So anytime you come across an equilateral triangle, you know the angles are all 60 degrees. All right. Isosceles triangle is different. Isosceles has 2 equal sides, like you have 2 eyes in your head, isosceles. And then this side is across from this angle. Like if this is a flashlight and you're shining it, that would be the wall that it hits. That's the opposite. And then this angle is opposite this side. And so these angles are going to be the same. So this angle is the same as that angle, and that side is the same as that side. Isosceles triangles always have to have 2 angles be the same and 2 sides be the same. Isosceles. And then the last one, there's also, now it's weird to me that they're talking about, you know, this is an equilateral, this is an isosceles. Then the last type of triangle is a scalene. Scalene triangles have no sides the same, and therefore no angles the same. But they skipped that and they went to right. I mean, a right triangle could be a scalene, but it isn't necessarily by definition. It could also be isosceles. It could not be equilateral, because equilateral triangles always have angles of 60, not 90. So a right triangle has a 90-degree angle, and then they give a special name. The side across from the 90-degree angle is called the hypotenuse. Hypotenuse. All right. All right. So the hypotenuse is side. Oh, they gave us a right triangle. The Pythagoreans figured out about right triangles that a squared plus b squared equals c squared, right? You probably remember that. Pythagorean's theorem. So there's a 90-degree angle we're looking at, number 6 still. So we've got They've got it labeled D, B, and C, and angle 1 and angle 2. And so they said the hypotenuse would be D, the side opposite the 90-degree angle. The legs would be B and C. B and C. And if angle 1 was 45 degrees, then angle 2, well, let's see. We know this one's 90 and this one's 45 degrees. So to find the missing one, we would say 90 degrees plus 45 degrees is 135 degrees. And then we'd say 180 minus 135, and that would be 45 degrees. And so it's a 45, 45, 90. That's a special kind of triangle also. It's an isosceles right triangle. Because if these angles are the same, then the opposite sides would also have to be the same. So that's special. All right. And that was all I wanted to do with those. Let's see how much time. 11 minutes. Okay, I'll make another video for the next section. That was 7.1.